Okay, how are we focus-wise?
Wait, is it working?
Yeah.
So it's on right now?
Yeah. All right. Evaluating algebraic equations. So an equation is simply one expression equaling another. It would be something like this. X plus 3 equals 10. What we're going to do today is sort of playing a game. Okay? I'm going to tell you X equals 4. And then I'm going to give you an equation.
Okay.
X plus 3 equals 43. You're going to tell me, if we use this to evaluate this equation, is it true or is it false?
False.
So for example, in this one, we would say, okay, we plug the 4 in there. We've got a 4 and a 3. Wait, I thought you guys said it was going to be false. Isn't that 43?
No.
What's missing? Oh, there's a plus there. Oh, so what is 4 plus 3? Does 7 equal 43? So that's false. False.
So can I say 3 plus problem? Can we use whiteboard?
So, yeah, we'll practice in a minute. But the idea here is we're going to plug in the number and see if our equation is true. Okay. Let's do a few more examples because I want to show you what can come up. What if I had something like this? X divided by 2 equals 2. So I'm going to kind of end up with a fraction in a way, right? When I plug in 4, it's like 4 over 2, which is 4 divided by 2. Does that equal 2?
Yeah.
So 2 equals 2. That is true. Yeah, that's true.
Wait.
Let me do another one over here. What if I had something like this? If I had something like this. 0.1 times x. And a lot of times in algebra, when we have a variable, we just leave off the parentheses. Okay? So it'll just be 0.1x. And I say that equals 0.04. So what are we going to do? We plug our 4 in. 0.1 times. And you see how now when I plugged it in, I put those parentheses in there? Because I don't want to just write 0.14. Because I lost. This means 0.1 times x. So I'm saying 0.1 times 4. And I'm saying that with parentheses. 0.1 times 4 equals 0.04. How do we do 0.1 times 4? You guys know how to multiply decimals? So if I come over here and I write it like this. 1 times 4 is 4. Now, I don't actually bring this down. What I do is I count. Up here, I had one number to the right of a decimal. So I'm going to take my decimal and I'm going to move it one space over. So 0.1 times 4 equals 0.4. So this would be 0.4 equals 0.04. Is that true? That's false. What if I had something like this? 0.3 x equals 1.2. So I have to do what? What operation am I doing? 0.3 and what is x?
3 times what? 4 times 4.
So 0.3 times 4. Okay, so 0.3 times 4. I'm going to put the 4 up top. 4 times 3 is 12. There's one number to the right of this decimal. So I move the decimal one space over. So 0.3 3 times 4 is 1.2. So yeah, that is true. What if I had something like this? I'm just going to write this. What if I had this? 1/4 of x equals 1. 1/4 of x equals 1. Oh, what do I do now? So I'm gonna plug in my x, but I'm going to remember that this means 1/4. What operation is in between the 1/4 and the x? Times. So it's 1/4 times 4. How do we multiply a fraction times a number? We think of it as, we think of the number as a fraction, right? We could put parentheses or we could put a times sign. And then we multiply the top, we multiply the bottom. Is that true?
Yeah, it's true.
Yeah, 4 divided by 4, remember every fraction is a division problem, is 1. So that is true. So do you see how, like, when we start doing these algebraic equations, we're going to have fractions, we're going to have decimals, and we've got to be able to multiply the fractions and the decimals times whatever our number might be. And actually, the way that we're doing it today is this is going to turn into a way to check your work in algebra as we learn how to solve equations. So this is a really useful skill. Later in the year, or maybe next year, I'm not 100% sure yet, we're going to be doing something called systems of equations, which is where we have 2 equations together. And in order to solve those, you're going to have to get really good at plugging in a number into an equation and evaluating it. So the most important thing I think to remember is typically when you plug in a number, if I plug in 4 into this equation, typically what I'm doing is putting that number inside parentheses. But sometimes the parentheses don't matter. So let me show you a case where the parentheses don't really matter, which should be something like this. X plus 2 equals 6. So if I know that x is 4, if I think that x is 4, and I plug that in, 4 plus 2 equals 6. I could put parentheses here, but it doesn't really matter whether or not I should. So what is 4 plus 2? 6. So that's true. And then there's even one more level, or I guess even a little bit more complicated, which is what if I had something like this. 3x minus 2 equals 12.
3 times? Okay.
Yeah, you guys are saying it. So I'm going to do 3 times 4 minus 2. And what do I do first? Do I do the 4 minus 2 or the 3 times 4? Do the multiplication first. So I've got 12 minus 2, and that's 10. 10 does not equal 12. This is a symbol for does not equal. It's like an equal sign with a slash. Okay. So again, what was important here to remember that we've already studied is that order of operations, right? I'm doing the 3 times 4 first and then minus 2. So there's like order of operations problems inside of these types of problems. Let's do one more example. And I'm going to kind of combine everything now for you. So what if I had something like this? 1/3. Let's say x is still equal to 4. 1/3 plus 1/2 x equals 18 over 6.
Wait, I'm going to.
So I'm going to plug in my x, which is 4. So I've got 1/3 plus 1/2 times 4. And I'm asking, does that equal 18/6?
Wait. What I did?
So what do we do first? Do we do 1/3 plus 1/2, or do we do 1/2 times 4 first? Which one? Just say it. Times. So how do I multiply 1/2 times 4?
1 times 1 is 1. 8.
4 is really, you can just say it. Go ahead.
It's 4 halves, so it equals 2.
Okay, nice. So 1/2 times 4 is 4 halves. 4 times 1 is 4. 2, remember, technically it's 4 over 1. So 2 times 1 is 2.
And that equals
Does that equal 18/6?
No, it actually equals just 2. You have to do the 1/3.
So now I could simplify this. I could. You might not want to though, because what do I have to do here? 1/3 plus, can't I just add the 1 and the 4 and the 3 and the 2?
No.
Why not?
Yeah, you can. Because they don't have the same denominator.
Right. When I'm adding fractions, they have to have the same denominator. Okay. So I could do 6. I'm actually going to do what you guys said. I'm going to simplify it first. 1/3 plus 2. Does that equal 18/6? Sometimes we put like a little question mark, like does it? So how would I add 1/3 and 2? Well, let's remember that 2 is 2 over 1. So I have to get both denominators to be the same. What could they both be? Yeah, I can make 1/3, that's already a 3. I can make a 1 into a 3. How do I make a 1 into a 3? Multiply by 3, right? So what would I do to the 2?
2 times 3.
2 times 2. So 2, or 2 over 1, is the same as 6 over 3.
So
These are the same. Why did I do that, though? Yeah.
Well, because, like, how I do it is, what did he do to 3?
Yeah. What did we do to 1, right?
To get 3.
What did we do to 1 to get 3?
So, and then
We multiplied it times
3.
3.
So then you do 2 times 3.
So 2 times 3 gives us 6. So now I've got 1/3 plus 6/3. Yeah, that's 7/3.
And if you want to make it a mixed number, you can do with the 7/3, you can do 2 and 1/3.
Nice. We could also call this 2 and 1/3. Now, in algebra, I prefer improper fractions to mixed numbers. So we're probably going to keep it as 7/3.
So that's false.
But are these equal?
No. No, they're not.
How many thirds is 18/6? Or how many sixths is 7/3? Can we compare fractions if they don't have the same denominator?
6. So
Not very easily.
6. You can use 6 as the same denominator.
So we'd want to try to get our same denominator. And we could turn this into sixths. How many sixths is 7/3? Multiply the 3 times 2 to get 6. So multiply the 7 times 2 to get
So that's 14.
14. Oh,
So that's false.
it is false. But do you see now? It's actually closer than it looks.
Yeah, it is.
Right? It's only 4/6 off. So we really need to get the same denominator in order to compare fractions when we're doing this. So that's an example of a really complicated one, right? Where we had a lot of fractions and we're adding and multiplying and comparing. But let's just, well, actually we're going to practice. I'm going to turn off the video now. So you guys have this for reference. But now we're going to practice.
Can you use whiteboards?
Yeah. So